Hey everybody, it's Michael from Second Revision, and I'm going to go over a brief overview of PWM outputs, or the pulse width modulated outputs on the Arduino UNO. Here on the screen we have a good representation that is on the Arduino website of what a PWM signal is. So the pins on the Arduino with the PWM signal, pins, let's see, 3, 5, 10, and 11 have a 490 hertz frequency for the output. So that means that each of these green lines represents one cycle, and we will have 490 cycles per second. So in one of these cycles is our pulse width. And what happens is when you send out a pulse width of 25%, you will turn on your pin, your output, for 25% of that cycle. So there's 490 of these in each second, and in each cycle, this width is determined by the percentage of our duty cycle. So if you put in 0%, it turns the pin off. It's all the way off, there is no pulse width. As you start increasing that value, it starts to increase the pulse width all the way up to 100%. So let's say you put in 50%, it turns on the pulse width 50% of the cycle and then off 50% of the cycle. The same thing with 25%, it's on 25% of the cycle and then off 25% of the cycle. And what that does is that gives you an average voltage. So you can filter that out with a low-pass filter, and it'll end up appearing to be a voltage, but the Arduino UNO does not actually output, a voltage of 0 to 5 volts. It outputs a pulse width, and most, I guess, devices that you can buy online will interpret that as an average voltage, but not all of them. So you can get into trouble if you don't filter it out sometimes. But just for some simple projects, this works fine for the pulse width. Like an LED, dimming an LED, the human eye can't tell the difference of the pulses, so you can dim the brightness of an LED using PWM, but if you view it through a camera or something like that, you'll actually see it flicker because it's turning on and off really quickly. So that's kind of a brief overview of what a PWM signal is. So what we're going to do is we're going to take our Arduino UNO and we're going to use the function analogWrite, which writes out this pulse width to the pins 3, 5, 6, 9, 10, or 11. And they have some different frequencies for the PWM signals due to the different timers in the Atmega 328P. We can go over that on a later date. The other function we are going to use is map. We are going to map one number to another number. So what the map function does is pretty much rescales a number. So those are the two functions that we are going to use. So what I've done here is I still have our analog input set up from last time. We have our analog input on A0 connected to a potentiometer between 0 and 5 volts. So we have 0 volts on one leg, 5 volts on the other, which creates a potential difference of 5 volts between the two legs. And then our wiper is connected to our analog input on A0. This is one channel on the oscilloscope so that we can read that voltage. And then here on pin 3, I have connected another channel of the oscilloscope so that we can actually see the PWM signal. And what we're going to do is we are going to map our analog input signal to our analog output signal. So I've taken our code from last time where we're reading in our analog input on A0, and we are going to write it out to our analog output. So first thing we need to do is we need to tell our Arduino that we're using an output. So pin 3 is going to be an output. The next thing we're going to do is we're going to map our analog input function to a new variable. So let's just call it int PWM out. And we are going to use the function map, and the first variable that we need is the initial value that is going to be used for mapping. So we're going to use our potentiometer value, which is our analog input. Now the next number you need to do is the map function works on from low, from high, to low, to high. So this value is our potentiometer value, or analog input value. And what it's asking for is the scale. The first two numbers are the scale of our potentiometer value. So that's 0 is our low value, and 1023 is our high value. And then what do we want to map those to? Our new scale. Now the analog outputs, or the PWM outputs, are 8 bits instead of 10 bits. So they are 0 to 255 is the number we're going to use here for our high value. So 0 to 1023 and 0 to 255. So if we go back to our map function, and sorry about that, 0 to 255. So what this is doing is it's just going to map this variable from 0 to 1023 to 0 to 255 and store it in our PWM out variable. And then we're going to take that and we are going to analogWrite pin 3, and what we're going to write to it is our new mapped value. So take in the analog input and send it out the analog output. Simple enough. So let's save as a new sketch, and then we're going to upload it to our Arduino. So I typed everything in right, and now it's uploading. It's done uploading. So now let's pull up our oscilloscope here. In yellow is the channel we had before, which is our analog input value. And blue is now our PWM signal. So this is what a PWM signal looks like. We have our edge here. So each edge, so each duty cycle, so there's this first edge and this edge is one duty cycle. And in between that, we have our pulse width on and our pulse width off. So since we mapped, in that, if we look down here, it's actually approximately 490 hertz, which it said in the manual that it would be for the frequency. And if we take our analog input and we increase it, we can see that our duty cycle changes. So if I put it right there about in the middle, we go from 0 to 5 volts. When we put our analog input about 2.5 volts, we have half on and half off, 50% duty cycle. Start at this pulse, 50% on, 50% off, and then we start our next cycle. So that would be about 50% duty cycle, and you can see here, if we lower this to about 1.25 volts, it's approximately a quarter duty cycle, 25% duty cycle. We have 25% on, 75% off, and our output will follow our input. So that's just a quick lesson on PWM outputs and how to use them. You can, anything can control the PWM output. I just chose to use the potentiometer since we were already doing that. If we go all the way up to 5 volts on our analog input, our PWM output is fully on. And if we go all the way down to 0 volts on our analog input, our PWM output will be fully off. There we go. So that again is just a quick overview of PWM outputs. If you like this video, go ahead and give it a thumbs up. If you want to know something about the Arduino or want me to change something, do something different, please leave it in the comments. If you want to be subscribed about future videos, go ahead and hit that subscribe button, and I will keep trying to put more Arduino videos out there. And I'll have to try to come up with a little project or find a project online that we can go over. But yeah, that's it for today. Thanks for watching, and take care.